Let's see what we have in here. طيب. Well, in this lecture, I'm going to solve some problems in chapter 9. And as you can see here, the chapter 9 problems are similar to other chapters, especially chapter 4. The only difference here is we need to deal with complex numbers. So eventually we're going to solve circuits, we're going to find the current, voltage, Thevenin and Norton equivalent circuits, etc., as well as the input impedance. And it's going to be exactly the same scenario as the one that we used to have in chapter 4. So in this question, we're asked to find the Thevenin equivalent circuit with respect to the terminals A and B. Basically, what we are asked to find is V Thevenin and R Thevenin, or Z Thevenin. We're talking about impedance. Okay, so let's start with the V Thevenin. And there are multiple ways of finding V Thevenin. So finding V Thevenin is equivalent to finding V naught, because clearly V Thevenin is equal to V naught. V Thevenin is equal to V naught. So let's start to find V naught. There are multiple ways of doing this problem. The first one is actually you can apply mesh analysis. In this case, you need a super mesh. Or you can apply much easier is it will be much simpler if you apply a node voltage method. If you apply node voltage method, then you'll have one essential node, which is this one. Let me call it V1. And I'm going to set this one as the reference point, or the 0 fault point. And let me apply the mesh analysis. Let me apply the node voltage method. So if I apply the node voltage method, I will get the first equation, V1 minus 250. The angle is 0, so I can assume it's just 250. Divided by 20 plus J10. Then I will minus 0.03 V naught. Then plus V1 divided by 50 minus 300 equals to 0. So I have, this is the first equation. I can do, I can actually relate V naught to V1. So clearly V naught is what? Is minus J100 divided by 50 minus J100 multiplied by V1. So what I did here was I applied the voltage division rule over there. So if I apply the voltage division rule, I'm going to have the voltage at the impedance that I'm interested in divided by the summation of the impedance, or the equivalent impedance. Is it clear, Shabab, this stage?
I did not get it, Doctor.
Okay. So what happens here is that, so what is V naught in relation to V1? So what is, where is V1? V1 is from here to here, to the ground, so this is V1. Do you agree with me?
Yes, Doctor, we're with you, yes.
So what is V naught with respect to V1? This is similar to having I have capacitor. And I'm asking you to find the voltage across the capacitor. What should you do? What should you do?
Again, Doctor, what's the question?
If I ask you, if I give you this circuit and I ask you to find the voltage across the capacitor, what should you do?
It equals V1.
What's that?
It equals V1.
No, it's equal V1 if the source is DC, but we have a sinusoidal source.
It's Z multiplied by I current.
Okay, so what is the current?
You want V0?
Yes.
You can use a node voltage. No, I mean voltage divider.
Yes, that's exactly what we've been doing. So this one is exactly the voltage divider law.
Yes, the voltage, the R of the capacitor,
The
and
Z
capacitor and the resistor.
Yes, that's exactly what we're doing. Is it clear, Shabab, now?
Yes.
Okay, good. So now I will take this equation and I will substitute it back. So I just want to have one single equation because it's complex number, so I don't want to be worried about different things here. Okay, so if I take this equation and substitute, what I will get is the first term stays as it is. Nothing has changed with it with respect to it. The second term is 0.003 or 0.03 multiplied by 100, which is 3. Negative with negative is positive, so I'm going to end up with J3 V1 divided by 50 minus J100 and plus V1 divided by 50 minus J100 equals to 0. So let's try to actually solve this problem. We can do that by moving things around. So if I take V1 as a common factor here, then I will get 1 over 20 plus J10 plus J3 50 minus J100 plus 1 over 50 minus J100, or I can combine them together to get 1 plus J3 equals to 250 divided by 20 plus J30 plus J10. So if you have it, probably like your calculator will do this. Will do this for you. Will do this simplification for you. Anyhow, if you want to do it, then in this case you need actually the multiple ways of doing it. The first one is actually it will be much easier for you if you take the conjugate of the denominator over here and multiply both sides, the numerator and denominator, and then you leave the complex number in the numerator. The denominator is purely real. You can do the same here and the other side, but I'm not going to spend time on it. It's a matter of calculator. So what I suggest to all of you is you actually try to be as fast with complex numbers as possible. So try different methods. Try which method is going to give you the fastest way of solving problems with complex numbers. Because clearly the difficulty here does not lie on the problem itself. The problem, if it was all for a purely resistive circuit, it will be straightforward. We saw it multiple times. The only difficult point here is dealing with complex number, and it's not difficult. You need to just keep track of these numbers. Anyhow, if you end up solving this problem, you will get 500 minus J 250 volt. This implies that V naught equals to V Thevenin equals to 300 minus J400. ليلى؟
دكتور بالفاينل بيجي matrix of 3 complex number.
You will not be asked to invert a 3 by 3 matrix.
بس بيجي 2 by 2.
You might see 2 by 2 matrix, but you will not be asked to find to invert a 3 by 3 matrix, unless there is a way to actually simplify it.
Okay.
For example, this one is 1 by. You can see it as 2 by 2, or you can see it as like just a single equation.
Yeah.
Okay, another question, شباب. أحمد نافع.
ليش دكتور الخطوات مهمة بالفاينل؟
No, the final is multiple choice. I don't care about the steps.
Okay. شكرا.
But it's always good to have clear steps, because when you review things, if you don't show your steps, it will be really hard for you to go back. So you need to resolve it again.
Yeah. شكرا.
Mohammed?
Can you go to the question? Shouldn't we say for the right loop that V1 minus V0 over 50, and then plus V1 over 0 minus V1 over minus 100J?
V0 minus?
We say V1 minus V0 over 50, and then plus V0 over minus 100J.
V1 minus V0 over 50 plus
V0 over minus 100J.
V0 over minus 100J.
Shouldn't we write this in the equation, in the first equation? Or why did you combine the 50 and the minus 100? I don't get it why.
Okay. Oh, I see your point here. So if I remove this one, if this one is not shown to you, what will be the node voltage equations? You'll get P1 minus 250 divided by 20 minus the current source, and then the other one is V1 divided by 50 minus J100, صح?
Yes.
Okay, that's exactly what we've been doing here.
Okay.
There is no current flowing here.
Okay. Thank you.
Okay. So we found V Thevenin. So let's find Z Thevenin here. The multiple ways of doing this. You can apply test source and measure the other quantity. If you apply test voltage source, you'll be asked to find the test current, and if you apply test current source, you'll be asked to find the test voltage source. An alternative approach is you apply. An alternative approach is you use or you try to find the short circuit current, and from the short circuit current you can take the ratio of the Thevenin voltage over the short circuit current, and this will give you the Thevenin resistance or Thevenin impedance. It turns out this approach is very straightforward. The reason for that is, if you see here, if you have a short circuit, then this component will be parallel with the short circuit, so it will be 0, which implies that the voltage here is 0. If the voltage is 0, then the current source here will have a zero current, and it will act as an open circuit. So let's see how the circuit looks. And this is the location of the current source, but since here we are trying to find the short circuit current, we have a short circuit in parallel with negative J100, and this is going to give us the parallel combination of them will be 0. So the parallel combination of them will be a short circuit. And the voltage of the short circuit will be 0, which is the voltage that controls the current, which means that the dependent current source has a 0 current, which implies that a current source with 0 current is actually an open circuit. So now let's find the short circuit current, and it's very straightforward. So what is the short circuit current here? We can easily apply Ohm's law. Divided by the summation, which is 20 plus 50, which is 70, plus J10. And this is going to give you 3.5 minus J5 ambience. So now you know the Thevenin resistance, you know the short circuit current, so you can find the Thevenin impedance. So the Thevenin impedance will be the Thevenin voltage divided by the short circuit current. If you do that, you will end up with 100 minus J100. And this transfers to the following circuit. So the Thevenin voltage was 300 minus J400 volts. And the Thevenin impedance will be, the real part of it will be 100. So the real part will be a resistor. The imaginary part could be a resistor, it could be an inductor or capacitor, depending on this sign. If this is positive, then it means it's an inductor. If this is negative, it means a capacitor. So here it's negative, so it's going to be minus J100. And this is A, this is B. Any questions, Shabab? The Kareem?
Yes, doctor. I understand until the Thevenin. Then how did we get the capacitor that's minus 100 J?
Well, if you have a complex, if you have an impedance, then for an impedance you can get you have the impedance of the resistor, which is the resistance itself. The impedance of the inductor is J omega L, and the impedance of the capacitor is minus J omega C. So omega is always positive. L and C are always positive. So R is always real. The thing is, like, if you got something like this, the X, let's say, A plus JB. So A is always a resistor. Now for B, if it's greater than 0, it's an inductor. If it's less than 0, it's a capacitor. This is clearly, you can see it here. The impedance of the inductor is positive, the impedance of the capacitor is negative.
Yes, okay. Clear, thank you.
Okay, let's take this exercise, and I think this one is taken from a very old final exam. So in this exercise, on this problem, you're asked to find the Thevenin voltage and the Thevenin impedance. So the Thevenin voltage, we need to find the open circuit voltage between A and B. We're given that the source is 60 and cosine 5000 t plus 30. So this one is equivalent to 60, or the phasor form of this one is 60, 60 and the angle is 30. Notice here that the embed or the elements, we're getting the value of the elements, not their impedance. So the first step we need to do is to actually draw the circuit and capture the impedance. So for the impedance, or write the impedance for the inductor is j omega L. Omega is 5000. L is 2 milli. So the impedance will be J10. For the capacitor, it's going to be minus J omega C. So this is going to give me minus J20. So now I need to draw the circuit where everything is in the phasor domain. So the source that I have is 60, the angle is 30. Then I have a 5 ohm resistor. This is IX, now it's in phasor. I have an inductor with omega 10. I have a dependent voltage source. The value of that is 8 multiplied by IX. We know IX is the current, this current. And I have a capacitor with impedance J20. This is A, this is B. Okay. First of all, let's find Thevenin. So Thevenin is VAB. So what is VAB? Here, if I assume that the current in this branch is I0, this voltage is V0, then I will have VAB equals to V0 by KVL plus 8 or negative, plus 8 IX minus J20 I0. But notice here the following. This is an open circuit, so I0 will be 0. So there will be no current flowing in this direction. So this implies that this term is 0. So VAB, or Thevenin in this case, is 8 plus 8 IX plus V0. So what is V0? What is V0 here?
You can use KVL on the other loop.
Not really. You can do it directly.
Oh, use voltage divider?
Yes, I'm going to use voltage divider because here this current is 0. So technically this circuit is separated from that circuit. Okay. Remember here, if the current is not 0, if I0 is not 0, you cannot apply the voltage divider. You do that. So this is, I'm sorry, this is V0. IX is going to be 60 the angle is 30 divided by 5 plus J10. Okay, now I have the values of the expression for V0 and Ix. So I can go ahead and substitute. So if I go ahead and substitute, if I go ahead and substitute, I will end up with the following expression. So this implies that I will have 5 plus J10, 8 plus J10. So this is the expression for the Thevenin voltage. And if I simplify it, I write everything in polar form and multiply. Again, I guess in most of your calculators you can mix and match. So you can perform this multiplication with some terms in polar, the other terms in rectangular form. If your calculator does not allow this, then you need to convert everything into polar form and then perform the multiplication. And this is what I'm going to do. But if your calculator does it for you, then don't waste time on that. Okay, this is the Thevenin voltage. And if we go back, we can see that that's the value we're getting. Yeah. Okay, any questions, Shabab? Mohammed?
I just want to make sure to find V0, I can just say that V0 equal Ix time 10J. Is that correct?
Yes.
Okay, thank you.
It's exactly the same. You can see it here. So the difference between Ix and V0 is just a factor of J10. Okay, now let's find the Thevenin. Let's find the Thevenin impedance. So in order to find the Thevenin impedance, again we have two choices. You can either apply a test source and find the current, or you can apply a, or you can use the find the short circuit current and find the short circuit current, and from that you can find the value of the short circuit current, and from the short circuit current you can take the ratio of the Thevenin voltage over the short circuit current, and this will give you the Thevenin impedance. So what I will do, I will use the second approach, this approach. I wrote it this way, but let me double check if we can do it with the other approach. We still can do it, I'm sure of that. Ix in this case, if you apply test current and then you try to find it, well, it might be a bit complicated if you apply a test source. You can try it, but there's some problems where applying a test source is really easy. Okay, so let's see. Let's see what happens here. So let's find the short circuit current. Then from the short circuit current, we can find the Thevenin impedance. So how many equations do I have? If I want to say, well, clearly here, it will be much easier if I use the mesh current method. So how many equations do I have to solve for in order to find the mesh current method?
2.
Why?
1.
For the I source and the IX.
For the I short circuit and the IX.
Yes.
Well, for this problem, I need 2. The reason for that is it happens that IX is a mesh one of the mesh currents. So I don't need to have a separate equation for that. Okay? So this simplifies the problem. Otherwise, I might end up with 3 equations. So I need to do some substitution in order to reduce it to 2 equations. So let's apply the mesh current method. So minus 60 angle is 30 plus 5 IX plus J10 IX minus I short circuit equals to 0. So if I simplify it, I will end up with 5 plus J10 IX minus J10 I short circuit equals to 60 angle is 30. Or if I write it in a rectangular form, I will get G. So this is the first equation. The second equation requires applying the mesh current method in the other circuit, or the second circuit, or the second mesh. So in this case, I'm going to if I simplify it, I will end up with So I have 2 equations, 2 unknowns. I can apply Kramer's rule to find it. It's really easy here because it's simpler because one of the C2 here is 0. So this will simplify the calculation a little bit. Anyhow, if I solve for it, I will end up with a short circuit current equals to -1 to -132 plus J 2.93 and Ambience, or in a polar form, this one is 3.21114 Ambience. So now I know the short circuit current. I already found the Thevenin voltage, so I can take the ratio here. and I'm gonna end up with 21.4. The angle is 96.4 units off. Let's see if it's exact. Okay, any questions? Okay, let's see what we have in here. Okay. So this problem is asking us to find the impedance, and the impedance will be a function of the frequency. So we're asked to find the impedance between, the first one is between A and B. So looking here. So this is the first question. For some reason, I did not turn off my email notifications. طيب, so what will be the first step in analyzing this circuit?
The impedance at C and D will be cancelled.
No, before that, I need to do something before that. So I need to write the impedance for each single element. So we're given the value of the inductance, the capacitance, but we're not given the impedance. So if I use the fact that ZL and draw the circuit with this substitution, then I will end up with this is C. Okay, now everything is in terms of impedance, so I can easily find the impedance. So the first step here is, you notice when you look into the impedance between A and B, and J22 ohm, this one, and that one do not have current. So this implies I don't need to include them when I want to calculate the impedance. So let me start with the first simplification. So you can see here the first simplification, I have minus J 5 ohm in parallel with 8 ohm. So this is the first simplification. So I'm going to get minus J40 divided by 8 minus J5. I can simplify it, I will end up with. Again, here I'm using, I don't have a calculator, but if you have a calculator, you can simply ignore this step and move directly to this result, 2.25 minus J 2.6. So now what I have is the parallel combination of these two resistors. So let me draw it this way. Okay, so I have the parallel combination in series with negative J20. So I can add it to the circuit. If I add it, it will be and this value will be 225 minus J 3.6 minus J20 is 23.6. Okay, so the next step now is to take the parallel combination of 2.25 minus J23.6 with J15. And the parallel combination of those will result in, I'm not gonna spend time on it. It's something that we are all familiar with. So you take this value, multiply it by J15, divided by the summation of 2.25 minus J23.6 plus J15. And if you do that, you will end up with okay, so the impedance between A and B is simply the summation. So it's going to be 52.62 here. Plus J 72.11 ohm, or Boda form is 89.2, the angle is 53.5. And if I go back to the solutions, the closest one to this is that one. I might have lost something in the approximation here. So that causes the difference between not getting 86, but getting 89. But again, here the angle is 53, which is exactly the same as the angle we have. طيب. So now we found the input impedance between A and B. We can do the same for input impedance between C and D. Abdullah?
So if you need to find A and B, we ignore the resistors on C and D and do the opposite.
Yeah, why we're doing this?
So we can find for A and B.
No, why we're doing this? Why we are ignoring?
I'm not sure.
طيب, who wants to help him?
Can I answer?
Yes, go ahead.
Because it is in series with an open circuit.
Yes, so no current is flowing.
Yeah.
So their contribution to the circuit is negligible. They're not contributing to the circuit.
Oh, okay.
So any element with zero current does not contribute to the circuit. Good. So now if we want to find the impedance between ZCD, in this case we need to ignore the 45 and 6 millihenry. Because again, they are in series with open circuit, so no current is flowing through them. Ahmed?
الدكتور الحين بالاختبار بتجينا مسائل طويلة زي كذا.
كيف تجيك مساء طويل؟ تبي يعطيك الاختبار أحمد؟
سم.
تسلم. تبي يعطيك الاختبار. It depends. There's some long problems, some short problems, but it depends. And sometimes it depends on the way you solve it. So if you use this approach, it might take you a very long time. Again, here I don't have a calculator, so if I have a calculator, I'll probably like skip some of the stuff, some of the steps here. But it really depends on the way you solve this problem. Some problems are long, some problems are will not take you more than 20 seconds. So there's a balance between them. طيب. So the second part is asking us to find the impedance between C and D. And the impedance between C and D is exactly the same. We're using exactly the same approach. Here is another approach that might be faster. So instead of actually drawing it this way, what I will do is I will draw it this way. And maybe this will eliminate some of the mistakes. I call this one Z3, Z2, Z4, and Z1. This one is 25. So if I simplify it, I will end up with so this one is Z2 in parallel with Z3 and Z4. And finally, what I will get here is this impedance is Z2 in parallel with Z3 plus Z4. Okay, so CD is going to be J22 plus, I'm getting Z1 in parallel with Z2 parallel with Z3 plus Z4 plus 25. Okay. So I did not calculate the any intermediate value. So what I will do now is I will calculate each one individually. So Z2 in parallel with Z3 is going to be, this is the value that I calculated last time. Again, Z2 here is what? Where is Z2? What is Z2 here?
-20.
Nope. Z2 is 8. Z3 is what?
Uh, 15.
No, minus J5. Z4 is what?
J15.
J15. Z1 is what?
Minus 20J.
Yes. You see what I did? Well, first of all, I ignored 45 and J30 because they're not going to contribute. Instead of like solving all of them, what I did was I represent them with impedance. So Z1 is minus J20, which is this one. Z2 is 8. Z3 is minus J5. Z4 is J15. Okay, now I concluded that the impedance between C and D is simply J22 plus the equivalent impedance, which is pretty straightforward in this case. So now what I need to do is I need to find the values here. And I have 8 in parallel with minus J5. This is the impedance. Then if I take this one, which is I calculated, add to it Z4. Z4 is simply J15. I will get 225. Okay. So now I have this impedance, the entire impedance here, in parallel with Z1. Z1 is minus J20. So if I calculate Z1, and if I find the polar form for the polar form of it, okay, I'm going to start a new page. Okay, let me move things up. So ZCD will be J22 plus the value I found here, plus 25. And this is going to give me 36.39 plus J 45.53 ohm, or 58.3, 51.4 ohm. And if I go back here, I think I have it. Okay, any questions about it? You see, this approach might be simpler because I don't need to do any intermediate calculation. So everything is left until the end. Okay, maybe if you do this approach, it will not take you more than 3 or 4 minutes to solve this problem, so it's not that long. Okay, the last problem that I want to solve is this problem, which is very straightforward. What I want to do here is this is just a simple calculation here. So I'm asked to find the voltage across the inductor. And in this case, I have two sinusoidal sources. So the first thing that I need to do is I need to draw the circuit in phasor form because I have sinusoidal sources. So if I do that, I will get, so what's the phasor form of cosine 1000 t plus 45? It's going to be 1. The amplitude is 1. The angle is 45. Then the impedance of the resistor is 2 ohm. The impedance of the capacitor is minus J1 over omega C. Omega here is 1000. So if I do the calculation, I will end up with minus J5. Then the impedance of the inductor is going to be J omega L. So in this case, if I do the calculation, I will end up with J. And finally, this source, the phasor form of this one is 1. This is the amplitude. The angle is minus 45. Because I need to write it in a cosine form. So sine 1000 plus 45 is equal to cosine 1000t plus 45 minus 90, which is cosine 1000t minus 45 degrees. Ali?
Doctor, what if we have different omega here?
Okay, if you have different omega, then in this case, you will need to apply what?
We will do the same thing, but we will then...
Superposition.
Exactly. So you need a superposition. So you have two different sources.
Okay. Thank you, Doctor. It's clear now.
Okay, now if I want to find VL, what I need to do is actually, first of all, I need to combine the sources. I have current sources in parallel, so the combination of all of them would be then I need to find, because this is the voltage pass and this is the voltage across the inductor, which is the same as the voltage across the capacitor, which is the same as the voltage across the resistor because they are in parallel. So now we need to combine them in parallel. So the equivalent impedance is going to be and if you solve for it, you'll get 106.58. So now if we find the equivalent impedance, you will have, this one is square root of 2. The angle is 0. You will have so what is VL here?
Z by A
Z multiplied
by I.
I. Yes. which is 1.5. The angle is 58. Here you are asked to find the steady state current, the steady state voltage. So what you need to do is you need to go back and use inverse phasor transform. So if you use inverse phasor transform, and the amplitude will be 1.5, the angle cosine, then the cosine of the frequency will be the same, 1000, will be the same as the frequency of the sources, but the phase will be the phase here, and if you do the calculation, you will see it over here. Okay, any question?
Doctor,
Yes, doctor.
can't we use source transformation before adding the Z and make it easier?
For adding what?
Before adding the impedance.
We're not adding the impedance, we're taking the equivalent.
Okay.
So the problem is similar to you have a resistor. If I ask you what's the voltage here, and you will say that the voltage will be the voltage across the parallel combination. So you combine these sources, then you combine the resistor.
Oh, okay.
Any questions, Shabab? If you don't have any question, thank you all very much, and good luck in your exam. If you have any question, please send me. Please make use of the discussion channel on Teams, and I encourage you all to, if you have any question, if you know the solution to any problem, if someone asks a question, you know the solution, you can go ahead and participate. If your solution is correct, I will give you a thumbs up. If your solution is not correct, thank you very much. I will make sure that everything is. I will correct the solution. I will provide you with the correct solution. For the exam, again, it's multiple choice. So for multiple choice questions, it's very important that you sometimes you don't know the solution. So you need to make an educated guess. What do we mean by educated guess? It means that if you have, for example, 4 choices here, then you guess one of them without attempting to solve the problem, you will end up with a chance of getting it right 25% of the time, or a 25% chance of getting it right. If you solve for it, then you're stuck, say, like at the middle here. You're stuck, for example, at this point. Then, and you start guessing. So you guess, for example, if you're stuck at this point, then you're probably gonna eliminate C and D, and you will have 50% chance of getting it right. So before moving to the following question, so if you're stuck with one question, before we move on to the following question, make a guess based on what you've covered so far, what you've discovered so far, and this will increase your chance of getting it right. If you leave it until the end and then you start guessing them, then the chance of getting them right is really low. Right. Any other questions, Shabab? Abdulaziz?
Yes, doctor. When will we receive the score out of 60 for the classwork score?
When I grade the quiz and grade the homework.
And that's possibly before the final or after?
لا تقفاني يا عبد العزيز.
Okay. Thank you.
Ali?
Doctor, are the majority of the quiz the final question about the new material? Or?
Yeah, there will be like 60, I think, something, or 60 above something for the new material.
Okay.
Yeah, the majority will be in the new material. Ahmed?
Okay.
دكتور كيف احول من الريكتانجلر الى البولر؟
Your calculator. Your calculator can do that. If you want to do it manually, then you can use rectangular to polar.
Yes.
You mean you're getting, this is what you're getting, صح?
Yes.
Right. So in polar you need an amplitude. So the amplitude will be this one. And then you need the angle. The angle will be tan inverse of B over A. But your calculator can do that for you. Use your calculator. Do not do it by hand.
جزاك الله خير.
الله يذكرك. طيب. I have your exam papers with me, so if you want to pick them up. طيب الله يعطيكم العافية. علي.
دكتور the exam بتوزع الأوراق ناخذها ولا بس عشان المراجعة؟
كيف؟
أوراق الاختبار اللي
No, some people ask me about their exam paper. If you are on campus and you want to collect them, you can stop by. Otherwise, I'll probably bring them to the final exam and get rid of them by handing them back to you.
So you will come with them in the final exam.
Inshallah, most likely.
Oh. Thank you.
إياك.